Today we're going to solve using our factoring methods, so make sure you have your binders. You may need your calculator for some mental math if you can't do the mental math, but we're going to solve these things we've been factoring for a really long time now. So let's go ahead and get started. We get too far ahead of ourselves, okay? Things we need to know prior to starting these. Again, we have to remember our 4 ways to factor. We're always going to look for a GCF, okay? So when you sit down and start these, first question you should ask, is there a greatest common factor? Okay, after that, then we base our method of factoring on the number of terms. Okay, if we have 4 terms, we're going to factor by grouping. If we have 3 terms, we're going to look to do a trinomial factoring. Okay, so then you already know how to factor, but do we know how to use it to solve? AKA solve for x, get x alone. Okay, get an answer or a solution for x. So that's what we're going to look into today. Example, step number one. Step number one, we want to make sure that we get our equation in standard form. So again, that highest exponent to the lowest exponent, and make sure we equal the expression to 0. So this one's already set equal to 0, which is good. Now we're going to look at the trinomial here, and we're going to factor it. Again, you heard me say trinomial. First thing you want to look for is a GCF. Is there something common between all 3 of these terms? You'll notice that we have x's in the first 2, but the third does not have an x, therefore we do not have a common factor here. So when we see trinomial factoring, again, first thing we're going to do is make 2 sets of parentheses. So 2 sets of parentheses. Notice a equals 1 here, so that's nice because how do we get x squared? We take x and we multiply it by x. We skip that middle term and we jump to that last term. So here we have 14. So again, we want to think of factors of 14. We got 1 and 14. We got 2 and 7 and nothing else. But again, remember, we can also have a -1 and a -14 and a -2 and a -7. It all depends on the sign of that middle term. Okay, so you'll look here, and as we look at these combinations, we want to look to combine them to get a positive 9. So again, we don't want to deal with the negatives because our middle term is positive. So 1 and 14 would get me 15, but 2 and 7 gets me 9. So here's where I would go plus 2 plus 7. Now if we check the inners, 2 times x gives me 2x. And x times 7 gives me a 7x. Combining these two, we do get the 9x that we're looking for here in the middle. Okay, so that's how we would factor it. Now again, it's set equal to 0. So our third step is to set each factor equal to 0. Now again, factor is the parentheses. So the parentheses we created, we're going to set 2 equations equal to 0. So we're going to have x plus 2 equals 0. And then we're going to get x plus 7 equals 0. Again, this is the steps that we're going to follow as we factor and solve. And the next, we're going to learn why. So how do I isolate x and get x alone? Inverse operations. We subtract 2 from both sides. So we're going to get x equals -2 in our first equation. And then we subtract 7 from both sides over here to get x equals a -7 as our second solution. Okay, so this is the process we're going to follow as we factor the next couple examples. Why are we setting each factor equal to 0? Okay, so it's like we're asking ourselves the question. I'm thinking of 2 numbers. They multiply together to equal 0. My first number is 7. What is my second number? So essentially, if I put 7 on the first blank, what number has to go on the second blank to equal 0? Hopefully you're thinking of 0. So what that means is when our product, when we multiply something together and we get back the answer of 0, that means one of the numbers has to be 0. Okay? So it either has to be 1 or both of the numbers to get back 0. We can't multiply 2 and 6 to get back to 0. So we know that one blank would have to be 0. Now we don't know which one, so we're going to assume both. That's why we take both factors and set them equal to 0. Okay, we assume that both have to equal 0 because we don't know exactly which one. Why we're setting it equal to 0. Let's go ahead and try another example. So here we have the example 4x squared plus 22x plus 10 equals 0. Again, first thing we want to do is make sure it equals 0, which we have that. Now we want to take out a GCF if we can. Now if we look, 4, 22, and 10 are all divisible by 2. So I'm going to factor out a 2. Do they all have x's? They don't. So the only thing I can take out is a 2. So I'm going to write that out front. And then in parentheses, we're going to write what we get after we divide it out. So 4x squared divided by 2 gives me 2x squared. 22x would give me 11x when divided by 2, and 10 would give me a 5. Okay, again, still equaling 0. So now that I took out a GCF, now I'm going to look at what's in parentheses and factor that. Okay, so factoring, there's 3 terms, so this means we're going to do trinomial factoring, meaning we're going to do 2 sets of parentheses. Okay, to get 2x squared, we're going to have a 2x and an x. Now, because we have a positive sign over here and a positive in the middle, that means both of my signs are going to be positive. And then we're skipping the 11 and we're looking at the 5. So what are some factors of 5? We literally only have 1 and 5. Now, this is where it gets tricky because we don't have a equals 1. So we have to remember that whatever number gets put on this second blank is getting multiplied by 2. So we could put the 1 there or we could put the 5 there. So let's just say we want to put the 5 there. We take a guess. You might see a pattern, but we're going to take a guess. So I'm going to put a 1 here and a 5 here. So this is where we have to check our inners to make sure we get 11x, because 1 and 5 combined together is not going to give me 11. So that's where it's a little confusing. So inners would give me an x. Outers 2 times 5 gives me 10x. There, when we add 1x with 10x, we do get the 11. So that's how we are getting to 11x, because the 5 ended up getting multiplied by the 2 in the beginning. So again, we're not done because we're solving here. Okay, now here we want to note that last time we had 2 solutions. The 2 solutions, the number of solutions matters on your exponent. Your highest exponent tells you how many solutions there will be. So because I have 2 here, that means I'm just going to focus on the parentheses here. So I'm going to take 2x plus 1 equals 0, and I'm going to take x plus 5 and also equal that to 0. The reason I'm pointing out the number is because you might think that we have to take this 2 and set it equal to 0. If I take 2 and set it equal to 0, there's no x to solve for here. And 2 does not equal 0. So we actually just get to ignore the 2 out front when there's no variable with it. So when it's just a number, we don't have to worry about it. So now I have to solve each of these equations to get x alone. So again, we're going to do reverse PEMDAS. Subtract 1 from both sides. We get 2x equals a negative 1. X is not alone yet, so we have to divide by 2. So x is going to equal a negative 1/2 because 1 does not divide by 2. So we leave it. The other solution, we subtract 5 from both sides. X is going to equal negative 5. So again, we needed 2 solutions because my exponent was 2. So let's try another. Here we have 3x cubed minus 27x squared plus 24x equals 0. Again, making sure it's set equal to 0 is our first step. Then we want to look for a GCF, and I see a GCF of x for sure because they all at least have an x term. But if we look at the numbers then, is there a number that's common between all of them? And it looks like 3 does divide into all of them. Okay, so then we're going to divide out a 3x. I'm going to put that out front. And what's left over? Well, here we would have x squared, and we'd have a negative 9x, and then we'd have a positive 8. Again, still equal to 0. So we took out our GCF. Now we look at what's left over in those parentheses. It's a trinomial, so therefore we're going to use our trinomial factoring methods. So again, we start with 2 sets of parentheses. I love that we have just an x squared because that means I have an x and an x. Then I skip the middle term and I look at the 8. I want to think of factors of 8. So we got 1 and 8, 2 and 4. And remember, we also have negative 1, negative 8, negative 2, negative 4. Now I know that they're both going to be negative because my middle term is negative. So when my last term is positive and the middle term is going to be both negative or both positive. So we can cross off our positive solutions. Again, 2 negatives make a positive or 2 positives make a negative. So when that third term is positive, the signs in our parentheses will be the same, whether that be 2 negatives or 2 positives. When the third one is negative, then we have 1 positive, 1 negative in our parentheses. Okay, but here I want to look at the numbers that combine to give me a -9, and it looks like we're going to have a -1 and a -8. Again, check your inners. -1, -1 times x would give me a -1x. Outers would give me a -8x. Together gives me a -9. Don't forget to bring down your 3x and set it equal to 0. So again, now we're going to take those sets of parentheses and we're going to set them equal to 0 because we're solving. So x minus 1 equals 0 and x minus 8 equals 0. We're going to add 1 to both sides. So x is going to equal 1. That's our first solution. We're going to add 8 to both sides. So x is going to equal 8. And then I just want to double check that I have all my solutions. So I go up and I find my highest exponent. This one says 3. So where's the third coming? Because I only show 2. So remember in the last example when we had the 2 out front, the 2 didn't have an x. But now this time we have a 3x out front. Because there's an x with it, we're going to set the 3x equal to a 0 as well because it's something else being multiplied. So then when I solve for x, I divide both sides by 3. 0 divided by anything still gives me 0, so my third solution here would be x equals 0. So you always want to double check to make sure that your exponent, your highest exponent, matches your total number of solutions. Example 4. This one's different because notice it's not equal to 0, so we want to make sure we set it equal to 0 first. Okay, we could move the x squared, but the problem with moving the x squared is then it would become negative. We don't ever want to make x squared negative, so we're going to move the other stuff. So we're going to move 9x to the other side, and I'm going to move the 8 to the other side. So we're actually going to have 0 equals x squared minus 9x plus 8. And now we would look for a GCF. Is there a GCF in all three of these? There's not. So since it's 3 terms, trinomial means 2 sets of parentheses. We just factored the same exact one actually, so we know that it's got to be -1 and -8 from the previous example. Again, that still equals 0. So then I'm going to set both of them equal to 0. X minus 1 equals 0. X minus 8 equals 0. We add 1 to both sides here. X equals 1. And we add 8 to both sides here. X equals 8. So again, we have 2 solutions here. Let's just double check that our highest exponent has a 2. Notice here that our highest exponent is a 2. Therefore, 2 solutions is enough. And we can move on to the next example. This example of the day then, here we have 5x cubed equals -9x squared plus 6x plus 1. Again, we got to get it equal to 0, so we want to keep that highest exponent positive. So we're going to move the stuff on the right to get to the left. So again, we're going to add 9x squared, subtract 6x, and subtract 1 all to the other side here. Add 9x squared, subtract 6x, and subtract 1. So we're going to get 54x cubed plus 9x squared minus 6x minus 1. And again, that all equals 0. So then we look for a GCF. Is there a GCF and something in common with all of them? There's not because of that 1. The 1 doesn't have an x. It's not divisible by 6 or 3. So there's no GCF, but notice there's 4 terms. So with 4 terms, this is when we factor by grouping. So we group the first 2. We group the second 2. Now we look for a GCF in the first 2. And it looks like the GCF is going to be 9. And they also share 2 x's, so 9x squared. So then we divide 9x squared to both of these terms. Okay, so 54 divided by 9 is 6, and then there'll be 1x left over. And then 9x squared divided by 9x squared, anything divided by itself is 1. Don't forget to leave the 1 there as a placeholder. Now notice this -6 is negative. Only thing they have in common is 1, so I got to take out a -1. We get 6x plus 1 then in parentheses. And again, that's what we wanted because we want our parentheses to do the same. Because once they're the same, then we take 6x plus 1 and then 9x squared minus 1. And that's now what equals 0. So now we have our 2 parentheses set equal to 0. So now here's where we set them equal to 0 and solve them individually. 6x plus 1 equals 0. And 9x squared minus 1 equals 0. So then we get 6x equals a -1. Divide both sides by 6. So x is going to equal a negative 1/6. And then this one gets a little bit more complicated because we have that power of 2. So we get 9x squared. 9x squared equals 1. We divide both sides by 9. So we get x squared equals 1 over 9. And we got to take the square root of that. So we got a square at the top and the square at the bottom. Thank goodness they're both perfect squares. So x equals, we got to do a plus or minus because we took the square root. Square root of 1 is 1. Square root of 9 is 3. So that one's a little bit more complicated. Hopefully we don't see a ton of those on our practice. But just so we have it in our notes, there is your final answer. Now again, we got to double check we have the right amount of answers. So we go up here, our exponent is 3. Do we have 3 answers? We have 1 over here, and then because of the plus or minus, there's 2 more over here. So we do have 3 answers, therefore we'd have enough, and we would be able to move on to the next row. So I want to thank you for taking good notes, and I'll see you when I see you.